Remember the story of Atlantis, the city swallowed by the sea? It's no longer just a myth, it's a warning. Since 1880, sea levels have risen nearly 9 inches, and they're accelerating faster than ever. By 2050, coastal flooding could cost the US over $100 billion annually, submerging homes, roads, and entire cities. To combat this, coastal communities are investing heavily in seawalls, breakwaters, and revetments. However, inland-focused construction and material companies, now newly tasked with coastal infrastructure, have overlooked critical structural and environmental challenges. Their approach, placing solid concrete or metal walls against the ocean's relentless force, and then continuously adding costly reinforcements, is fundamentally flawed. Take cavitation erosion, a severely under-researched issue that affects 100% of coastal defense structures. Imagine throwing rocks at a brick wall. Even though the wall can theoretically withstand the force, without structural modifications to diffuse the pressure, the concentrated impact of the rocks will weaken the wall over time. Seawalls face the same fate. Their flat, rigid surfaces lack adaptations to absorb and dissipate wave energy, leading to gradual erosion and inevitable failure. For example, the recent Hurricane Milton caused severe flooding, damaging several seawalls and costing millions in critical infrastructure. And the grievances don't just stop there. Traditional structures disrupt natural wave movement, causing scour, increasing wave turbulence, and accelerating erosion. Sand gets trapped or redirected in a process called longshore drift, which completely destabilizes the shoreline and harms marine ecosystems by eradicating biodiversity. My name is Brinda Roy, and I'm the founder of EcoSurge Materials, where we've developed a gyroid-structured material based on triply periodic minimal surface geometry, a breakthrough solution that outperforms traditional materials. Unlike conventional concrete barriers, our material evenly dissipates wave energy, reducing the wave reflection by 50% to instead evenly distribute pressure, thus minimizing erosion and longshore drift disruptions. It also integrates with natural shorelines, allowing marine life to thrive and grow within its porous structure while maintaining natural sediment flow. Our material withstands 70% more wave-induced forces than steel and 50% more than concrete. It may seem counterintuitive that a material with holes could be stronger than solid concrete or metal walls, but these voids are mathematically arranged to evenly distribute stress, preventing localized weaknesses and reducing force impact to render heavy waves and winds close to harmless. Compared to conventional concrete, our material is lighter and requires less material per linear foot due to its porosity and increased durability, thus increasing cost effectiveness. By using traditional concrete casting and existing and feasible technology for production, we use molds to produce prefabricated modular blocks that eliminate the need for bulk material supply for on-site filling. Our ability to customize our molds allows seamless integration into existing coastal structures, which enables both new construction and the retrofitting of aging coastal defense structures. At EcoSurge, we are the first in the materials industry to solve both structural and environmental challenges of coastal defense in a cost-effective, scalable manner. Traditional material suppliers haven't innovated yet because they're stuck in a red ocean, competing on bulk supply, price per unit, supply chain control, and mass production efficiency. These companies supply projects in a broad range of industries: roads, bridges, general infrastructure, highways, without specializing in any single one. Their materials must be standardized for multiple applications, making them inadequate for coastal defense, which has completely different needs. The larger, multinational material companies with higher budgets do have specialized solutions, but without targeted R&D, their approach is simply to add more material and reinforcements, which their dominance over the supply chain allows for. This way, they increase costs without true innovation. This lack of specialization in the infrastructure material industry is a misstep EcoSurge will capitalize on to create a blue ocean. The US is expected to spend $400 billion on seawalls over the next 15 years. The World Bank projects that global coastal defense investment could reach $18.3 trillion by 2100, with annual spending hitting $170 billion per year. With 85 to 98% of these costs tied to materials and construction, EcoSurge is uniquely positioned to lead the industry as a first mover in coastal protection specialization in the materials industry. We offer the only material specifically created for coastal protection that solves the existing structural and environmental problems. We do this with far less material needed per linear foot than traditional solutions, and without the need for expensive reinforcement such as rebar and riprap, and also without the costly maintenance. Non-customers like environmentalists such as the World Bank and the OECD are pushing for alternatives to traditional structures. The natural solutions they promote, such as living shorelines, will not be strong enough to protect against rising sea levels. Our material offers a hybrid approach that aligns with regulations while ensuring durability. I've optimized our material through dozens of advanced simulation trials where I've determined the ideal gyroid TPMS parameters. Structural validation through FEA analysis showed that under high loads such as 50 kPa pressure, the material experiences minimal stress buildup and near zero deformation. It has a factor of safety of approximately 1.45 times 10 to the third, exceeding the typical FOS of 3 to 4 for traditional concrete solutions exponentially. The results of my CFD simulations confirmed that our material effectively slows down wave velocity, evenly distributes pressure, and eliminates erosion-causing dead zones. A team of researchers across 7 institutions have successfully fabricated and tested a gyroid breakwater using our validated dimensions, proving that our material can be mass-produced using traditional concrete casting so that we can produce our patent-eligible MVP and prototypes for testing by several construction firms in New York this coming year.